Today we get to discuss the relationship between these three graphs here. I'd like to start with the one we're most familiar with, the f of x graph, right? What we've been doing up to this point is looking at this graph, deciding what's going on as far as the slopes and whether it's increasing or decreasing, and then the curvature, whether it's curving downward or if it's curving upward. And when f prime of x is a positive value, well, that's when it's increasing, right? That's when your slope is going uphill. When your f prime of x equals 0, well, there is a stationary point. In this case, it is a maximum because the first derivative test, if you look at it, it then starts to decrease afterwards, and that is when your f prime of x values are negative. We still have f prime of x values here that are negative, and then when we have our another derivative here that's 0, well, this one's a min because due to the first derivative test, it's then going from negative to a first derivative positive, which means it's increasing again. And that would be a minimum. The point of inflection up here, this is, well, you take your critical points of your second derivative and you figure out which ones are either 0 or which ones are undefined. And then if it's changing curvature, remember what curvature changing is. That means the second derivative is going from either negative to positive, or it's going from a second derivative that's positive to a second derivative value that's negative. Must change signs, okay? So change signs. And if you see here, we have concave down, and then at this blue point we do have concave up, so it is curving. The curvature is changing, and this right here does represent where the second derivatives are negative, and this one right here represents where the second derivative values are positive. So it is changing concavity. It's a point of inflection. So let's think about everything we know. So the f of x, so your f of x function can be either positive or negative, right? And I think we know that, right? Here's the x-axis, and this is where your first derivative is, your original f of x function is positive. Here's where your original f of x value is negative, and that gives you, positive y values or f of x values, or negative y or f of x values. Then we have the first derivative. Well, as you can see from the graph here, when your first derivative is, when your first derivative here is positive in this region where it's going, where x is less than a, all right, well, positive means it's increasing. The next interval here, we have the first derivative values that are negative. They're going downhill, and that is where our x values are in between a and c. That interval is decreasing. And then over here, f of x is positive again, and that is when your x values are greater than c, and that is an increasing region again. Then the second derivative, notice how the second derivative is different, okay? For the second derivative, that is addressing concavity, and that's different at b. So I'll just write it up here. So the second derivative has a negative value. That would be when x is less than b. That region is concave down, as I already have on the graph there. And then over here, well, when your f prime of x values, f double prime x values are positive, that is where, in this graph, where x is greater than b, well, that's where we are concave up. And if you can know all those little pieces to the puzzle, the rest of this lesson is going to be pretty straightforward. We've discussed this in class, but since you're going to see these words in the word problems here, just a general reminder, remember when you can take the first derivative, right? When you can get a value there, well, that's when it's differentiable, right? And then if you can't take the derivative, it's not differentiable. The second derivative, well, if you can take the second derivative, what that means is it's twice differentiable. You could take the derivative twice, right? And you're going to see that term as we go through these problems. Just wanted to remind you. Here we have a twice differentiable function, and it is the domain is -9 to 9, and we want to know, well, it's telling us we have inflection points. We have 3 of them, okay? So there's one here in the green dot at -3.5, one at the green circle here at x equals 2, and then one at x equals 8. Those are points of inflection. Before I even continue with the problem. If those are points of inflection, you know it's going from concave up to concave down. And then there's another point of inflection, so it changes curvature again, then it's going concave up. And let's see what else we know here. We want to determine what could be said about the values of f of 2, f prime of 2, and f double prime of 2. All right, well, I'm going to focus on 2 here, x equals 2. And, well, I think the first thing we can identify here is, well, what is f of 2, right? F of 2. That's a little light. F of 2. Well, f of 2 is 0, right? The first derivative is, as we've been discussing, the tangent line, right? The tangent line, and, well, the slope of the tangent line, shall I say. And since that slope of the tangent line, it's going downhill, that is a negative first derivative value. Next, they want us to identify what the second derivative value is at x equals 2. Whoops, I'm writing a 0. So let's see what happens here. Well, remember, when it's concave down, that's when the second derivative is negative. When it's concave up, the second derivative is positive. All right, well, at x equals 2, didn't they say that there was a point of inflection there? I believe they did. It's changing concavity, and that is a 0 value right there. So we can now evaluate this, and what we can say here is these are drop-down boxes here, and they're going to give you either a positive, negative, or 0. We know that f of 2, we said that had a 0 value. F prime of 2, well, f prime of 2, didn't we say that was negative? Oh, I write, yeah, f prime of 2 there. That is a negative value. So, and then f double prime of 2, f double prime, we also said that was 0. All right, so those are our answers for this one. Submit. Here we have another example. And as you can see, this one is same concept. They're just giving us the choices right here. Let's see which one is the right answer. We have a twice differentiable function. Again, we can take the derivative twice, and the domain is between -9 and 9. 4 inflection points, one here at -5, one here at -2 when x is -5, -2.3, and then when x is 2 and 7, x is 2 and x is 7. Those are points of inflection, which means it's changing concavity. It's curving up, down to up, then up to down, then down to up. Now we're going to focus on -2. We want to see what the f of -2 value is, the f prime of -2, and the f double prime -2. Again, focus on positive, negative, and 0. Okay, that's what we can get out of this. We are at -2. X equals -2. Okay, as a general reminder, this point right here is a point of inflection, and that is not x equals -2, that is x equals -2.3, right? X equals -2 is right there. It is 0, okay? So f of -2, the y value is 0. Next, we can figure out the first derivative. That's f prime of -2, f prime of -2. F prime is the slope of the tangent. Oh, I'm sorry, I'm at the wrong point. Is the slope of the tangent line at -2. Either way, that is an uphill positive slope, which means the slope value is positive. The first derivative is positive. Next, we have the curvature. Well, again, be careful here. The point of inflection is at -2.3, which means x equals -2 is clearly in the concave down region. Concave down region means, oh, I don't want to change the color there. The second derivative value at -2 is concave down, it's negative. So now we can go here, take this information right there, and figure out what the answer is. Well, we said that f double prime of -2 was negative, which means that's less than 0, and f of -2 was 0. And well, 0 is less than positive, which means f of -2 is less than f prime of -2, which is our answer. It appears to be this one right here. Okay, submit. Up to now, we've been looking solely at the original f of x graph. But now it's time to associate what the f prime and f double prime x graph looks like with respect to our original function. So here's an original f of x. This is something you can easily do in your head to take the derivatives. If I gave you 1/3 x cubed, well, it's a cubic function. And it's continuous, and then if you take the derivative of this, well, just algebra, this should make sense, right? You take the derivative, you get x squared, and you're familiar with the x squared graph. This happens to be our first derivative graph, right? That's a function onto itself. And that is differentiable. And if it is twice differentiable, well, that means we can take the second derivative, which we can. That becomes 2x. And, well, you know what the graph of 2x looks like. I have it right here for you. Going left to right, we see that this graph is increasing, and, well, it looks like it's always increasing, except for maybe this point is 0 here. So let me draw some tangent lines here, right? So we have derivatives here, right? We have these, and then all of a sudden it kind of narrows out. So it's positive, it's a big positive, and it keeps getting smaller positive until it hits 0, which means you're going to have first derivative values that are positive. Whatever this value is here is that numeric value. Let's focus on -2 and 2. So we're going to look at f of -2 and f of positive 2, f prime of -2 and f prime of positive 2. And then the same thing with the second derivative. Here, well, on the f graph, -2, well, that's 1/3 times -2 cubed, which is -8/3. Okay, so when x is -2, your y value is -8/3. And then when it's a positive 2, you're going to get a positive 8/3, which means when x is 2, your y value is positive 8/3. Well, on the first derivative graph, let me just do this in white. So that is just x squared. So if you plug in a -2 there, well, that's going to give you a value of 4, which means when x is -2, your y value is 1, 2, 3, 4 right there. And when your y value is 2, you're going to get well, 2 times 2 is also 4, and that's why the graph looks the way it does. There's your values there. And down here, well, if this is my f double prime, right, if I plug in a -2, that's going to be 2 times -2, that's -4. And then if you do the same thing for the positive here, that's 2 times, that's positive 4. Which means when x is -2, 1, 2, 3, you have a -4 down there. And when x is 2, 1, 2, 3, you have a y value of positive 4 up there. So here we have a negative y value and we have positive y values. That's what the f of x graph tells us. But now the first derivative, when x is -2, the first derivative is positive 4, right? Which means you have a positive slope. You have a positive increasing slope. Over here, when x is positive 2, you also have a positive first derivative, which means you have a positive slope at positive 2. And I think we can see that that is also positive. This positive 4 right here means that the slope right here is up 4 over 1. And the slope here, positive 4, means you're going, same thing, up 4 over 1 at that location. That's what that represents, and that's why they're plotted here. So let's go to the second derivative now. Second derivative at -2, well, that's negative value. Remember, when your second derivative is negative, that means you're curving downward. This is a negative, this is curving downward. But then you have something here where it looks like the curvature is then going upward. Okay, well, that's why your positive 2 has a positive 4 here, because the second derivative is positive. It's curving upward. This is concave up. And then when your second derivative has negative values, well, that's concave down. And you can tell that from the graph. So that looks like at x equals 0, there's a point of inflection. Well, if at x equals 0, there's a point of inflection, that means that on the second derivative graph, you should have a 0 value, right? So the second derivative at 0 is 0. And, well, let's see here. You also know the slope of the tangent line. Look at that. It's 0. It's horizontal, which means down here on the first derivative graph, when the first derivative at 0 equals 0, you have a 0 slope. To recap, right here we have positive first derivative values, a 0 first derivative value, and positive first derivative values. That's why your first derivative graph looks like this. You have positive first derivative values, a 0, 1, and then positive first derivative values. The original graph is concave down before 0 and then concave up after 0, which means you should have negative second derivative values, a 0 at 0, and then positive second derivative values after 0. Now, what about the f prime of x graph? What would the slope of the tangent lines be for that graph, right? What would this slope be? Well, that slope is 0, but well, if this is the first derivative graph, it would be the derivative of this graph. Same thing over here. If I were to pick a point right here, well, that slope right there, that represents the slope of this function, which is f double prime, and we have positive values. That's why we have a positive value at x equals 2, And well, over here, we have a negative slope, right? We have a negative slope at -2 here, which means down here we have a negative value, and it actually is going down 4 over 1. Here you're going up 4 over 1. And if you didn't see it coming, well, that's why you have a 0 value right there. So just remember that. The derivative of this graph is this function. Always know what graph you're looking at. They are giving us the derivative graph. We have f prime of x. So think about what the slopes of the tangent lines of this graph are, right? Here, if you were to draw tangent lines, well, there's a 0 slope, there's a -1, right? Over here, I'm just going to randomly draw a +1. And, well, the slopes of this graph would be the derivative of this graph, which means if this is f prime of x, that's an f double prime of x value of 0. This is an f double prime x value that's negative. Here's another 0, here's another 0. And this is where second derivative values are positive because it's the derivative of this graph. Whereas to find all the intervals that are concave down. Well, concave down, we're looking for the second derivative values that are negative. Well, notice right here is the 0 point, so it looks like it starts there where x is -1. And, well, even though we zero out here, we continuously go down negative until this point where x is 4. Which means you're concave down between -1 and 4. This right here is not a point of inflection because notice how the second derivative is negative and then the second derivative is negative. It does not change concavity there. Let's analyze this one now. We're given a first derivative graph again. We have f prime values in front of us. So let's see what they're asking us. We have the f prime derivative graph. Determine the values of x, if any, where f double prime are 0 on the interval -9 to 9. Well, that, like we just said, if this is the f prime graph, well, then that means that the slopes of the tangent lines are the derivative of this function. Looks like we have one there, and then as I keep traveling this way, we have another 0 slope right here, which is that. And then, even though that doesn't look like it right there, that one is going to 0 out. So we have another one, here's another one, here's another one. So in the interest of time, all of these x values where we have f double prime equal to 0 would be at -5, at -2, 0, 2, and that is at 4 right there, so 4. All right, what can we infer from this graph? They are giving us the second derivative. It's twice differentiable. We have the second derivative graph. What do we know? We have points of inflection. They're giving us we have a domain from -9 to 9, and we have points of inflection. They're giving it at -4, at -2, 0, 4. Those are given to us. What do we need to find out here? What inferences can be made about the graphs of f, f prime, f double prime on an interval 0 to 2? Well, these are the questions that are going to be asked to you. So it's kind of laid out for you. We'll get to them in a minute. But first, let's focus on 0 to 2. All right, so this is where x equals 0. And is where x equals 2. So we're focusing on that interval there. All right, so in that interval, they're first asking us this. We want to know from the figure above, it can be seen that the graph of, so f double prime. Well, that's what we have. This is f double prime. All right, don't forget, this is f double prime. And we want to know, on this graph, between 0 and 2. Well, on this graph, let me see what we have here. It looks like, well, this is positive values and this is negative values, which means I'm going to say that it has negative values. Okay, these are drop-down boxes, and they're going to give you some choices. These are the answers. Next, if you think about the slopes, right, this is an increasing function in this interval, so I can also say that it is increasing. Now consider the curvature. Well, the curvature of this graph is, during that interval, it's curving downward, so that I'm going to say is concave down. And that should make sense. What's next? Based on these observations, it can be concluded that, well, let's see, on the same interval, 0 to 2, All right, the graph of f. So now they're asking us, what can we infer about the original function f? Well, would that be concave up or concave down? Well, think about what we have here. During this interval, this is the f double prime x graph. In this interval, we have negative values. This is where your f double prime values are negative. So on the original f of x graph, that indicates concave down on the original graph. Concave down. Let's see, they say because f double prime is, well, that's because f double prime, we just said f double prime is negative there. Next question, on the interval, the same interval 0 to 2, the graph f prime. Now they want us to infer something about f prime. Well, the slope of the tangent lines for f prime would be f double prime. And on this interval, since our f double prime values are negative, that indicates that the slope of the tangent lines for this function would be negative. They'd be decreasing, right? They'd be slopes going down this way. So this is decreasing. And it's because, well, our f double prime values are negative. What can we infer about this one? We are given, please note what graph we have. We have the first derivative. All right, so the derivative of the twice differentiable function f is shown below. We have a domain, -9 to 9. The graph has inflection points at -3. Let me identify those. We have one at -3. There we identified it, but I'm going to do it again. At x equals 2, and that's it. Here we are looking at the f prime graph, and we have an interval of 2 to 4. So here is 2 to 4. We're looking at this region. And they want to know, well, again, this is the f prime x graph, and we have, this is the positive values for this f prime x graph, and these are the negative values for that. So we have negative values, which means if we were to infer this way, that means that the function before it, well, that's the slope of the tangent lines. That means we'd have negative slopes here, and that function would be decreasing, right? If we were to infer something ahead of it, well, then we would have to look at the slopes of the tangent lines of this graph. And, well, this graph, the slopes of the tangent lines are going downhill until we have a 0 there at x equals 4, which is where it stops. So that means slopes of the tangent lines are negative. This is decreasing down here. And that means, that's a second derivative there, sorry about that. Those are negative. Before I infer too much here, let's see what they're asking us again. All right, so we're back here. So I have, from the given figure above, we want to know the graph of f prime. So this is the f prime x on the interval 2, 4. So we're looking straight up at it. This one is negative on this interval. And that's also going downhill, so it's decreasing. And we want to see what else we have. Concavity. Well, that looks like it's curving upward on that part, so we're going to say concave up. Those are what these drop-down boxes are looking for. Based on these observations, we can then conclude, well, what about the original function f? Well, remember what we just said up here. The original function is decreasing, so I'm going to write decreasing. They're also going to ask you to infer what about the concavity of the original f of x. And if you notice here, well, we just got done saying the second derivative value has a negative, so that would infer that the original f of x second derivative negative values means concave down. So we know that this is decreasing and concave down. Because f prime, well, f prime is this graph we're looking at, is decreasing because they have negative values. And, well, it's concave down because it's decreasing during that interval. Next, they want us to consider something about the f double prime function. Well, let's see, that right there, I'm going to say that would be negative because, well, we already identified it right here. I'm sorry, the second derivative is negative during this interval because f prime, well, f prime is decreasing. During that interval, it's going down, which is the slopes of the tangent lines, which would be f double prime. Those are the last examples. We're dealing with an interval. Now we're going to look at a specific point on the graph. In this case, x equals 4. All right, what can we infer here? The questions are below, and here we are given the first derivative graph. Okay, we're asked to, well, they're giving us some inflection points. We have one there at -4, -2, and 2 on this, the f prime graph. And they say, what inferences can we make about the f prime, f double prime at x equals 4? The questions are below right there, and here we know, here's x equals 4. And on f prime, when x is 4, it has a value of +5. And so on this f prime graph, when x is 4, we have positive value. We have a positive y value, or f prime value. And if you look there, since we are going from increasing to decreasing, and that would be a 0 slope, that right there is a relative max. And that's what they're going to ask you in this drop-down box here. This is a relative max on this graph, on the f prime graph. Next, what can we infer on the original f of x graph when x equals 4? Well, over here, if the first derivative is positive, that indicates that on the original graph f of x, that is increasing. So if it's increasing, it's going uphill. And this drop-down box over here, they're going to ask you, is there a relative max or a relative min? They're going to try to throw you off because they want to make sure you know which graph you're looking at. All right, we do not have a relative max on the f of x graph. We have one on the f prime of x graph. And what we're looking for is we have no horizontal tangent line here. We know it's increasing, so it has to be an uphill tangent line, and that's not a choice here. But they're going to give, we do not have a horizontal tangent line, and we don't. That's the true statement there. Now remember what this tangent line represents. That's the second derivative value, and since that second derivative value is 0, that's a possible point of inflection. It's a critical point. And to confirm it is a point of inflection, we see here that we have second derivative values that are increasing, they're positive, and these are right here, these are second derivative values that are negative, they're decreasing. And so we have concave up here on the original f of x graph, and here we have concave down on the original, let me write it down, on the original f of x graph. So over here we can say that we have an inflection point, and it is going from concave up to concave down, like we just said. And under this drop-down box, there's different choices, and this is the only one that is correct. They'll also ask you, is it an inflection point because you're going from concave down to concave up? They just want to make sure you know what you're talking about. Next, we can state that on the second derivative graph, this is f prime, which means we're talking about the slopes of the tangent lines of this graph. Well, at x equals 4, what do we have? At x equals 4, well, the second derivative is 0, so we can write that, we know that it is 0. And it is going from, well, the second derivative is positive, and then it's going to negative, so it is 0 going from, not growing, going from positive to negative. There's going to be different choices under this drop-down. This is the only one that is correct. So look at the graph and see if it makes sense to you. Here's another one. We're looking at a specific point. Here the problem is looking at x equals -5. So we have the second derivative. I always like to identify that first so we don't forget. We have f double prime of x here. And we're looking at x equals -5. We are looking specifically right here. We have our usual interval, and the graph of f double prime has points of inflection at -2 and 2. They're identified right there on the graph. What inferences can we make about the f prime, and f double prime graph right here at -5? Here are the questions below. There's the graph at -5, and this right here is the f double prime graph. So again, I just brought it too high there. So, well, what do we have there? At -5, I'm going to tell you it equals 0, right? It's right there, so we have a 0 right there. And that 0, notice how it's not changing signs here, okay? This is a positive value, then we have a 0 here, but these are still positive because these are all your positive f double primes. These are all your negatives down here, okay? The only thing f double prime negative is in this region between 3 and 8. Well, we're talking, so that means we have a 0 at -5 with no sign change. That will be important soon. And what do we have? Well, what does it look like? Is that a max, a min? It looks like we have a relative min. Next, based on the observations, the graph of f. Okay, so now what about f, the original function at -5? So right here at -5, we are going to say that f double prime at -5 we said has a value of 0. All right, well then think about that. When your f double prime x values have 0, those are possible points of inflection. Possible. We have to see if it's changing sign. We have to see if it's going from negative to positive or positive to negative. Well, we just said right here that it's going from positive and it stays positive. Well, if we have positive to positive, it's a possible point of inflection, but it's not. And so therefore, we have no inflection points. Furthermore, we can state that f prime, so now they're talking about f prime. Well, let's go back to the graph here. So f prime, this is where f double prime is positive and 0 and positive. Well, these are the slopes of the tangent lines of f prime of x. So that means that if you have increasing slopes here, then you have a 0 slope here, and then here you still have increasing slopes. Well, then on the f prime of x, those slopes would be going up and then 0 and then going up. Okay, so this right here, it's going to be a horizontal tangent line, but it's not a min or a max tangent line. It's just it's a non-extreme horizontal tangent line. If it's not extreme, it just means it's not one of the extrema, not a min or a max. So we can write that up like this. This f prime has a non-extreme horizontal tangent line. As I look at the drop-down choices for this one, while there are no inflection points, that's not one of the choices. And when your choice is not one of the choices, what you pick is they have none of the above can be ascertained. All right, this way when that comes up, you'll anticipate it. Let's estimate the values of x on this graph where we have mins, maxes, and points of inflection. And I'd like to talk about it this way. Well, right here is where, this is the f prime of x graph, so we have an f prime of x value of 0. Notice here, these are your positive f prime of x values, these are your negative f prime of x values. So you are going over here, these are positive, you have f prime of x values that are positive, and then all these values are where your f prime of x values are negative. So on your original graph, at this point too, what's happening is you have positive slopes, then a 0 slope, then a negative slope. That right there is a maximum. If you continue over here, well, this is another place where you have an f prime of x equals 0, but instead, from left to right, your derivatives or your slope values are going from negative, then afterwards they're positive. So on the original graph, what you might have there is you have negative slopes coming down to a 0 at 3 here, and then it's positive slopes. So there is a relative min. That's a relative min, and this over here is a relative max. Now, even though this one over here is another f prime of x equaling 0 at x equals -1, this one is not a relative max or min, because notice how these first derivatives, well, I mean, they're just positive right here. These are all your positive values, right? And they just stay positive, right? So if they're going from positive to positive, then no slopes are changing. So what might happen is this, you might have positive slopes, and then you have a 0 here at -1, and then it continues positive, because something like that might be happening. And so we have a relative min over here when x, it just says the x value, so when x equals 3, and we have a relative max when x equals 2. Now the inflection points are the second derivative values, right? If they are positive, it's concave up. And if the second derivative values are negative, it means it's concave down. Well, let's look at the slope of the tangent lines. So possible points of inflection are where the second derivatives would be 0. So there's a possible one, here's a possible one. And well, down here's another possible one. Let's see what happens with the sine values. Okay, so the sine, well, let's go left to right. Over here, my derivatives, the sines, oh, the derivative is the f double prime, right? There, they're negative. Here, your slopes are positive, and the second derivative are the slopes of this function. Since it's going from negative to positive, it's changing concavity, and we have an inflection point when x equals -1. All right, now what about up here? Well, here you have derivatives. You have a second derivative, because it's the slope of this function, is positive. And now they're going down, which means the second derivatives are negative. You're changing concavity. You have another inflection point at, let's see, what do you think that is over here? Let's just call that, I don't know, how about 0.7? All right, 0.7. And then we have one more down here at x equals, what is that, 2 points, I'll just call it 2.6. So I'm going to say over here at x equals 2.6, we have another one for the same reason. Your second derivatives are negative, your second derivatives are positive. That means you're going from concave down to concave up. And so we have them written all right next to each other here. It says estimate. So we're going to, I mean, this one is -1. I think we're all pretty comfortable saying. We are going to guess that one as 0.7-ish. If you said 0.75, whatever, 0.8, I don't care. And then we had one down here. Well, we said that was approximately 2.6-ish. So how about those three inflection points? Here we're asked to work backwards, if you will, the other way around. Instead of giving you a graph and asking you information from it, we are giving you information, and you are going to give us a sketch of that. Okay, now don't worry when you see the word sketch, please don't, it doesn't have to be exact. We just want to see approximate curves and some specific critical points, if you will. So let's graph what we know. All right, let's see. We have f of 0 is 0, all right, and so is f of 2. So that would be f of 0 and f of 2 right there. That's what we know. Next thing we have, so we did that. Next thing is, let me not do it that way, let's do it this way. Next thing, the derivative is positive. When it's greater than 0, it's positive. Whenever or if x is less than 1. So here's 1, and less than 1, we know we have positive slopes. So it's a root here, so we know that it goes through a root. So I have to make sure I go through the root, and I'm also not pretending, I'm drawing positive slopes. It's increasing, that's what that means. So let's see what else we know. Over here, we did that. We know the derivative at x equals 1 is 0. The derivative at 1 is 0. What does that mean? The slope of the tangent line is 0. All right, that's what this means. Next, the derivative is less than 0 when x is greater than 1. The less than 0 is negative. That means it's decreasing. It's decreasing whenever you're less than 1. But remember, we have a root there, okay? And you will always cut through a root, and it just decreases from there on in. And let's see what the last thing says. The last thing is, here we have the second derivative is less than 0. When that is less than 0, that means it is concave down. And it doesn't give us an interval, which means it's all real numbers. And if you see, this is a simple parabola, and it's concave down for its entire journey from negative infinity to positive infinity. I realize this is a long video, but it also covers material for 2 days. Okay, so if you're doing this on time, this is going to be Tuesday over here, and then this is going to be due Wednesday, and then after that, Thursday, we're back in class, and we'll start the next topic. Right? So page 190, so this is the one right here associated in Delta Math with the video. You're going to do that. And then you all should have a textbook at home, so we're going to do those 3 problems on page 196. And more importantly, this is in Google Drive, or at least it's in my Google Drive. So I don't know if just to make it a little bit easier, it's these 2 problems on the F prime graph, this worksheet right here, this one, the F prime graph worksheet, that's this one. So there's 2 problems on it. That's what they're asking you for. So if you want to just copy it at the end of this video, have at it. If not, it's in my Google Drive folder. Have a great day.